An audiogram with at least hearing thresholds at the 500, 1K, 2K and 4K Hz frequencies must be available for the calculation of target curves for hearing aid fitting. After the audiogram has been measured and saved, click on the icon for the speech mapping module in the module bar on the left. To start with a new and empty measurement, click on the New Measurement button and then on SM Measurement button. Prepare fresh probe tubes and apply it to the probe tube ports of the probe headset. Then calibrate it and insert it into the ear canals as shown in the video tutorial. Probe microphone measurements. First steps. Apply the hearing aids to the ear and select the test type percentile 65 dB from the test list. In the diagrams, the target response curve calculated for the 65 dB input level is shown with black, solid lines. From the legend on the right, it can be identified as NAL and L2 prescription targets. Also displayed are the hearing thresholds for left and right side as SPLogram. If you want to measure both sides in one go, select the symbol for both sides and then click on the Start button. The measurement starts with an emitting noise signal for setting the equalization for the room acoustics. The probe measurement itself uses a speech signal, such as the ISTS, as an input signal. With the probes, the amplified sound is now picked up in the ear canals. The measurement is automatically resumed after 15 seconds to avoid that initial effects of the hearing aid while adapting to the sound situation are impacting to the measurement results. After 45 seconds, the measurement stops and the results are displayed on the screen as averaged output curves together with the HI and LO curves indicating the total dynamic range of the amplified signal. The bar graph display can be made visible again by clicking the sleeping eye icon in the legend. The Percentile Analysis bar graph view provides insights to the real-time dynamical behavior of the hearing aid for louder and softer parts of the actual test signal. Speech dynamic become visible and speech processing features like dynamic compression can be visualized and checked. As the hearing aids have not yet been adjusted to the hearing loss, there is a certain difference between the measured average curve and the target curves. The output signal of the hearing aids must now be adjusted to the black, solid target lines using the manufacturer's software. Once the adjustment has been made, a new measurement must be carried out to check the corrections. This is an iterative process and requires several repetitions to achieve satisfactory results. To shorten this iterative process, the loop button can be clicked before starting the measurement. This enables a continuous measurement run in which the averaged response curves can then be adjusted to the target curves under visual control. As a shorter time constant is used for averaging when looping, the measurement must be repeated when looping is deactivated in order to verify the target adjustment of the output signal. There is an alternative representation to show the difference between the target curves and the measurement curves more simply. But this representation can only display curves for one side alone. As an example, select the right side. Then select the entry Match to Target/Response in the View drop-down list. The view will change to show the right side result in the left-handed diagram and a normalized target view in the right-handed diagram together with the task curve. The difference between the measurement curve and the target curve is now easier to read as a difference to the normalized target line at 0 dB. This allows tolerance specifications to be checked more easily. After adjusting the response for 65 dB input signal, the response curves for loud and soft input levels should also be checked and adjusted if necessary. 2 further tests have been prepared for this purpose and are available in the test list. The percentile 80 dB test is used to check the loud input levels, and the percentile 55 dB test is used to check the soft input levels. The results of all 3 measurements can now be superimposed on the screen. To do this, switch the target view to display all 3 target lines. Then reduce the view to only show the task curves and hide the distribution. This can be switched off in the legend. Now unhide the results of the 80 dB and 55 dB measurements to show it all in the same diagram. The results of the fitting curves can be printed into a report. For quick documentation, use the Print button located close by the Save button at the bottom of the window. This will create a printout that shows what is currently displayed in the measurement screen. For a more standardized report, use the Print Report Manager from the dashboard.